Okay, this would be my last video, and this is the video for assignment on PD. As you know, everybody has to do version 2, not version 1. Now let's look into the problem. What we have clearance, we have volume distribution, we have EC50. So first we have to look into this, and then we will do a number of calculation. Let's also look into the equation. What we'll use, we'll use from PKPD, we'll use these equations mainly. So now first question, calculate the percentage as Emax for plasma concentration of 0.321. So we have to use this equation. The equation is E is equal to E max times C divided by EC 50 plus C. So here our Emax is 100, C is 0.321 milligram per liter, EC50 is this one, 15.2, and C is this one, 0.321 milligram per liter. So now we have 100 times 0.321 milligram per liter divided by 15.2 milligram per liter plus 0.321 milligram per liter. I'm drinking coffee, sorry. So with this you will get your E of 2.0680. So using this equation we have an Emax of, E effect is 2.068%. Use the same equation, same thing. Only thing you are going to change, for this one, same equation, E is equal to 100 times 0.16 divided by 15.2 plus 0.16. This is going to give you 1.04%. Now the next question is asking, I think I have explained this thing very well in this class. Why is the magnitude on the is almost same as that concentration? Effect is the same as concentration, because one of the reason is because plasma concentration is this are significantly lower than EC50, and also another reason is that you see this, your concentration 0.16, effect was 1.04%, and when your concentration is 0.321, effect is 2.068. that means with the doubling of concentration, effect doubles. That means there is a linear relationship resulting, that's a linear relationship, you remember that. You see, resulting almost linear relationship between effect and plasma concentration. This is the reason why we have to choose this. Now we have to do a few more calculation. Target plasma concentration, CS target, to achieve target effect of 34%. As I have mentioned, this is part 2. We have in our note C target. If you go back to also equation, you see this? Nothing. This is same equation. You just write here C target is equal to E target or EC50 times E target divided by E max minus E target. So the same equation we're going to use here. Same the equation we're going to use here. C target is equal to E target times EC50 divided by E max minus E target. And here we go. E target is, you see this data is given in 34%, so you can use it 34. In that case you have to use, if you use 34 here, you have to use 100. But what we are going to do, we are going to answer is going to, so we are going to use 0.34 times 15.2 milligram per liter divided by 1. In case of 100 we put 1 minus 0.34, it is going to give you 7.830 milligram per liter. So this is going to be your CSS. So we are going to calculate CSS. This is our CSS is going to be 7.83 milligram per liter. And then now we are going to calculate infusion rate. To calculate infusion rate, we need this equation. R is equal to CSS times CL. So infusion rate we usually calculate in hour. So we have our CSS. We have to modify a little bit CS. Our CSS is what? Okay, CSS is our CSS is 7.830 milligram per liter times CL. Our CL is, this CL if you convert, this is our CL, and this if you convert to liter per hour is going to be, this would be 0.684 liter per hour. So this one we are going to use. So this CL is going to be 0.684 liter per hour, and is 535 milligram per hour. So your infusion rate is going to be 5.35 milligram per hour. Now loading dose. To calculate loading dose, always, if you remember, we have to use that normal equation that what we use, V is equal to dose by C0. So that means dose is equal to V. In case of C0 we will use CSS, steady state concentration. So our V is 10.6 times 7.830. Our dose is going to be 83 milligram. So loading dose would be 83 milligram. Okay. Now the last part. In last part we have 5 questions. We have to calculate target, maximum target concentration. As I have mentioned, we have to identify first what is E lower and E upper. In our case, here this is question, please design a multiple doses regimen for the patient to keep effect within 26% and 48%. So our E upper is 41%, E lower is equal to 26%. So if we use this one, it will give you Cmax. So Cmax at 41%. Cmax at 41% is going to be Cmax at 41% is going to be EC 50 times E upper divided by E max minus E upper. It's going to be EC50 is 15.2 milligram per liter minus 0.41 divided by 1 minus 0.41. That means your Cmax is going to be 10.56 milligram per liter. Similarly, you calculate Cmin. Use Cmin at 26% Emax. Use the same equation as above. It will give you 15.2 milligram per liter times EC is the E lower. See here, this equation, same equation you are going to use, just E lower. E lower is 0.26 and 1 minus 0.26 is going to give you 5.34 milligram per liter. So we figured our target Cmax was 10.56 milligram per liter. Target Cmax is 1 point because we have used 41. Always you have to use 41 to calculate, and then target minimum concentration is 5.34 milligram per liter. So we have now Cmax and Cmin. From that Cmax and Cmin, we have to calculate this. After calculation of Cmax and Cmin, we have to go back to multiple dosing. We have our Cmax, Cmin. Then we have, it is asking recommended dosing interval. We have to calculate tau, and tau has a equation like this: log Cmax divided by Cmin by K. We do not have K, we have Cmax and Cmin. So what we can do? We can convert it, log Cmax by Cmin. K is CL by V. So now you do this calculation. Cmax, we know, we have to get this from there. 10 and 5. So our Cmax log 10.56 milligram per liter divided by 5.34 milligram per liter divided by 0.684 liter per hour and 10.6 liter. This will give you 10.56 7 hours. But the question is asking you to choose. Our answer is 10 point. Our answer is 10.57. But you have to choose one. Always you have to go backwards. So this is our answer, 8. Okay. So we have now our recommended dosing interval. Now recommended dose. To calculate dose, so recommended dose. To calculate dose, we have to calculate C average. To calculate C average, using this information, we have to, if you remember, there's another equation for C average in the equation list of equation here. Our C average equation is this one. Okay, so now let's use the C average equation. So first you have to calculate the recommended dose, and loading dose, we need C average from Cmax. So we have to calculate C average from loading from Cmax. So C average is equal to Cmax minus C min divided by C max by C min. And if you put C max, C min from that calculation, 10.56 minus 5.34 divided by ln 10.56 divided by T4. This will give you 7.656 milligram per liter. Okay, so this is our C average. To calculate dose, so this is our C average. You see, it is not asking for C average, but to calculate recommended dose, we have to calculate C average. So for dose, we already know the equation. First, let's go back to the dosing rate equation. That's just dosing rate equation. I think this one. Here. So you have to this equation, rearrange that equation. Dose by tau, we are talking about this one, number 4. Dose by tau is equal to C average times CL by F. F is always 1. So our C average, 8. This, I think we calculated C average here somewhere. Anyway, so we have calculated C average. So I have showed you how to calculate C average. So C average was, your C average was C average is 7.656 times CL is 0.684 divided by F, which is 1. When there is no F, you just always 1. So our dose by tau is equal to 5.23 milligram per hour. So this is what? This is a dosing rate. So we have to calculate the dose. That means you calculate dose 5.23 times the hour. This will give you 41.9 milligram. this is your dose. This is, I think this is what recommended dose. So 41 point round to significant, so it's 41 point or 42 milligram, and the recommended loading dose to achieve the steady state concentration to significant. So recommended loading dose, again we have to go backward a little bit to calculate loading dose. We have to do some other calculations. To calculate loading dose, we have to calculate, we know that loading dose is what? DL is equal to DM, maintenance dose, which is this one, times RSCC. So RSCC is equal to 1 minus e to the neg k tau. This is tau. And then we calculate 1 minus e to the k, you have to calculate using CL by V, which is 0.046453. Tau is 8, we know that. We calculated tau there. This is our tau. So we have, and then this k we have calculated CL by V. So this k we have calculated like that. So your RSCC is 2.480. So you perhaps remember this RSCC is accumulation factor, and this equation is on the equation sheet. What is RSCC? There you go. This is RSCC. Once you know RSCC, you can calculate DL. Let's explain this. So DL is DM. Our DM is 41.9 times RSCC is 40 is 2.480, which is 104 milligram, and this is our answer. This is our answer is 104 milligram would be recommended loading dose to achieve steady state immediately. So this is all I had. I think you should be fine. It was in fact a quick video, and again, as I have mentioned, there will be no math problem from PD. No math problem from PD, so but there will be calculations. Thank you, and this will be end of my annoying videos that every day you have to watch about the semester. Thank you. See you during the quiz.